Hi students, this class let us discuss about the double slider crank chain. There are three major examples of the double slider crank chain. The first one is elliptical trommel, the second one is Scotch yoke mechanism, and the third one is Oldham's coupling. These three are the most usable examples of double slider crank chain. Here, this picture shows how the elliptical trammels works. When the link 1 and 3 slide along their respective grooves, any point on the link 2 such as speed traces out an ellipse on the surface of link 4. It is shown in the figure. In the figure, the bar link 2 is connecting the points A and B. The slider link 1 and 3 are sliders. Okay, and the slatted plate link is mentioning as a slatted plate. So here the x is equal to PQ, that is AP cos theta, and y is equal to PR, that is BP sin theta. That means that x square plus y square is equal to AP square. So similarly, you can know about the elliptical trammel. The second one is Scotch yoke mechanism. Scotch yoke mechanism is a simple type of mechanism which converts the circular motion into reciprocating motion. That is rotary motion into reciprocating motion. The power is supplied to the DC motor. Shaft and crank attached to the shaft which start rotating. As the crank rotates, the pin slides inside the yoke and also moves the yoke forward. When the crank rotates through clockwise direction, the yoke will get a displacement in the forward direction. When the crank rotates through the clockwise direction, the yoke will get a displacement in the forward direction. The maximum displacement will be equal to the length of the crank. The maximum displacement will be equal to the length of the crank. When the crank completes the next revolution, the yoke comes back to its initial position. For the next rotation, yoke moves in the backward direction. When the crank completes the full rotation in the yoke moves back to the initial position. For a complete rotation of the crank, the yoke moves to the length equal to double the length of the crank. The displacement of the yoke can be controlled by varying the length of the crank. This is the working principle. And the last one is the Oldham's coupling. Oldham's coupler is a method to transmit torque between the two parallel but not collinear shafts. Oldham coupling is a method to transfer torque between the two parallel but not collinear shafts. The components in the Oldham's coupling are disc, one coupled to the input, one coupled to the output, and the middle disc that is joined to the first two by tongue and groove. It has three discs, one coupled to the input, one coupled to the output, and the middle disc that is joined to the first two by tongue and groove. We know that the Oldham's couple is having three discs. One is coupled with input and other one is coupled to the output. The third one is in the middle disc that is joined to the first two by tongue and groove. The working mechanism has been described when three discs, one disc coupled to input of the shaft connect to another disc coupled to output of the torque. The center disc joins each other disc. The tongue and the groove as one side is perpendicular to other side of tongue and groove. Often, springs are used to reduce the backlash of the mechanism, though the working principle of the mechanism shows when three discs, one disc coupled to input to the shaft connected to another disc coupled to output tongue, the center disc and each other disc, the torque and groove as one side is perpendicular to the other side of the tongue and groove. Often springs are used to reduce backlash of the mechanism. The application of Ohlm's coupling is the Ohlm coupling performs as a type of fuse for machinery. Perform as a fuse for machinery. Exert a low relative force that uh, fortifies the support of the bearings. The driving and driven shafts gyrate at similar speed. There is no backlash and torsion in elasticity. The applications of Ohlm coupling is it can accommodate large radial misalignment. Comparatively, it is quite economic. It possesses low moment of inertia, robotics and servo applications, printer and coffee machines. Thank you.